Well, let's see what we can do with this particular radical equation. Now, if I isolate one of these radical expressions, say by moving this radical expression to the other side, then if I raise to the appropriate power, that appropriate power is going to have to be the third power, because this is a cube root. So I would have to raise both sides of the equation to the third power, which means I have to raise this binomial to the third power, which means I would have to write it down 3 times and multiply. And I don't think I want to do that. So I don't think I want to treat this as a radical equation to begin with. I think I want to see if I can make a substitution that will make it an easier problem to work with. Now, here's one thing you have to remember, one little trick you have to remember to handle this particular equation with a substitution. The cube root of x squared is equivalent to the square of the cube root of x. That's something you needed to remember about roots and powers on a term. And you may not have remembered that, so I'm pointing that out to you. The cube root of x squared is the same as the square of the cube root of x. And now that lends itself perfectly to a substitution. Let's let y equal the cube root of x. So then this term would simply be minus y, and this term would be 2y squared. See? I'm putting y in place of the cube root of x. And now I've got just a nice quadratic equation I can solve. Put it in standard form. And let's check and see if it's factorable. I think it will be. I believe that pair of binomials has their product, this trinomial. 2y times y is 2y squared. Minus 2y plus 1y gives me minus 1y. Plus 1 times minus 1's minus 1. So my two solutions here are, this is the obvious one, y equals 1. This is one that's not quite as obvious. Remember the little pattern? If the binomial is an addition, the solution is negative, and you find the number part of the solution by taking the constant and dividing it by the coefficient. So the solution coming from this particular factor is negative 1/2. So now I'll substitute back the cube root of x for y. So my two solutions that I'm going to continue solving are the cube root of x equals negative 1/2. So let's solve that one first. That's a radical equation, so we will raise both sides to the third power. That gives us x equals, what's the cube of negative 1/2? Well, that's negative 1/2 times negative 1/2 times negative 1/2. An odd number of negatives gives us a negative answer. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. So one of our solutions is x equals negative 1/8. Let's take the other one. So the cube root of x equals 1. So when I cube both sides, I get x equals 1, because 1 to the third power is just 1. So our two solutions to that original equation that we found are 1 and negative 1/8. So we should probably test them to see if they really work, because again, the original equation was a radical equation. So let's try 1. 1 squared is 1. The cube root of 1 is 1. 2 times 1 would be 2. The cube root of 1 is 1. 2 minus 1 indeed is 1. The value of negative 1/8, so if I plug in negative 1/8, the square of negative 1/8, well, that would be positive 1/64. And the cube root of 1/64 is 1/4. 2 times 1/4, is going to give us what? That's going to be 1/2. 2 times 1/4 is 1/2. And then the cube root of -1/8 is -1/2. Well, 1/2 minus -1/2 minus the minus makes plus. 1/2 plus 1/2 is 1. Both solutions work. Ooh, that last one there, I was kind of stretching your mental thinking there, picturing in your mind all that was going on. So you might want to do that, on pencil and paper, which at this point in time I don't want to take the time to do. Again, maybe another little task to help put you to sleep if you have insomnia.